Hi guys, welcome back to another video. And in this video, I'm going to be writing a Turing machine simulator in my own language. So if you have been following this channel, I created my own language called Pilot, and I put a compiler development series which consisted of the development of the compiler for that language. So I think in total there were 8 videos, so you could watch that if you want to, but the compiler for my language is written in C++, and the extension of Pilot is .py. So we're going to be writing a Turing machine simulator in my language. So the thing is, a language is said to be Turing complete when it can simulate a Turing machine. So we're going to be simulating a Turing machine in our language to prove that this language is Turing complete, which it is. So if you don't know what Turing machine is, you can watch this video of computer file. I think there are like many videos regarding Turing machines, but you can watch this and that would be good enough. Most probably, I assume you would have the knowledge of what a Turing machine is. It's a very simple thing. It basically is a one-dimensional array which is called as a tape. So this is a one-dimensional array. You read off the tape using a head. A head is basically a index pointer pointing to an index of the array at a certain offset. And depending on what you read, if you read a 0 or 1, you would write the value to whatever you want. You would shift accordingly, and then you would jump to another state card. This would be more clear when we actually implement this. So I have my Linux virtual machine over here. I'll actually close this. The reason is that I'm running this like my language works in Linux, so I have this Kali Linux instance running. So the thing is, this tends to be very slow sometimes. So I'm gonna be closing everything else. So whatever. So let's get started. So we create a new file. Let's call it vim.turing.py. First, we got to initiate the tape. I'm sorry. So what we do is we create a 1D array, and the way we create any array is the array name is the dimensions of the array, like n1 times n2, and then whatever the initial value should be. So we're going to be calling this tape, and then let's call this, let's give this a size of 10. It's going to be 1D array, and the name is tape, and then let's call this 0. Should I keep this in caps? One second. Let's just call it tape. Then we would have a read write head, and let's say the current index the starting index it would point at is let's say 0. Then we want to create some functions first. So what we'll do is we have a function called as render, and if you aren't familiar with this syntax, you can I'll put the link to the project in my the GitHub link to the project in the description down below. Over there, I think I've properly documented the entire syntax. See, I designed this language with simplicity in my mind, so it's going to be very easy to read. And even if you don't, if you have any familiarity with any language, this would be a piece of cake to read because it's a very easy language. So whatever. So we have a function render which would render stuff onto the screen. So what we want is we want first to display, let's say in yellow color, let's say Turing machine simulator, and then display dot red. What do we display then? Let's display the current read write head. Okay, I'm sorry. Let's display the current read write head in red. Current read write head state, and then we output read write head, but we gotta pass this every time. So we'll pass it. What we'll do is we'll take in some input. We'll call it head state, and then we output the head state. And let's do that. And we gotta create a function render tape. What this would do is, okay, I'll just keep this in small. Render tape. What this would do is it would range from 0 to 9 as I, and then it would render a tape. So it would do display. Let's do inline. Inline means basically displaying on the same line, and we display tape I and then space. And we do this, and after this we call the render tape method, and then over here till let's do what do you call it, infinite loop. till this we just call the render method, we sleep for 1 second, we clear the screen. Okay, so let's see whether this works or not. Okay, I forgot to provide this an argument. So in the render we provide this the read write head state. Let's compile this. This should work. Sorry. Yeah. Let's clear this and let's run it. So yeah, obviously nothing happens, but at least we have this working, right? So current read write head state is 0, and yeah. So okay, let's do another print over there. Let's I'll open another. Okay, not like this. I'll open. I can't switch back. Okay, wait. View scaled mode. Is it in scaled mode? If I just switch it so it's out of the VM, I don't know what happened. Didn't work like this before. 1 second. Should I go full screen mode? Okay, now it works. I hope the recording isn't disturbed. I mean, that would be very sad, but okay, I have another instance over here. So I'll go inside this, and then over here I'll open turing.py, and now over here I'll run it. So that's how we're gonna be doing this. Yeah, and then we yeah, cool. So first of all, before we call the header thing, we want to clear the screen first. That's the first thing, and let's get rid of this. And over here I also want to display like 1 second. So this video is not only this video is going to be technical in the sense that we're going to be creating a Turing machine simulator, but I'm going to be also trying to make this look good by adding colors and paddings and stuff. So if that's going to be boring maybe for some people, but I just want that to be looking good, so whatever. And what we do is like, I don't need to write this so properly, like in red color current read write head state, in yellow color we have a heading with Turing machine simulator, but I'm doing it for the sake of doing it, so whatever. So tape state, let's do current tape state. I think that should work. And then we just call the render thing. So, and yeah, okay, now let's create a function. Let's create a function new line, which would take in, let's say, new line counter, and then it would range from 1 to, should I do it like this? Yeah, 1 to new line counter, and then it would just display an empty string. And now over here, let's call, I could have just written display empty quotes over here, but I have to show that this language works programmatically, like we can call functions and stuff. So yeah, whatever. So we have this does nothing, but yeah, we at least have something on the screen. Now what we want to do is we want to initialize the tape state first. So, and first I want to create, I want to add some kind of borders. So actually I was working on some prototypes. So if I just do vim.box.py, you see this is what I had in my mind. So I'm going to be implementing this. So I think it was range 0 to I think it was 45, and then we just simply display in inline this, and then call new line 1, and then after this we again range 0 to 45, and then display inline, and then we call the new line. I think the calling new line every time is kind of irritating now, but I'm going to be sticking to this. And yeah, we have this. So what we do is okay, let's do something. We want to implement that also, right? This thing also, we do this, and then the way we print stuff is we have an empty quotes over here, and then we have this. Should this work? It should work, I guess. Okay, one second. Why is Vim so irritating? Yeah. Okay, let's see. Okay, so something went wrong. Oh, this has to be inline. Okay, that's the first thing. This is inline and this is inline, and I think I have to call the new line method over here also. Okay, let's do one thing. Let's call the new line method. Should I call the new line method? Yeah, I mean, this should work fine, and then we do it inline. Yeah, this should work. Like, this should at least. And there is some issue with the spacing. I think there is some extra space over here, so we could just get rid of that. And okay, of course, this works so slow sometimes. Yeah, but still, it is kind of, you know, laggy. Like, there is some extra over here. Let's range till 40. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, let's range till 40, and let's this also range till 40. Oh, okay. Cool. So this is good. We at least have this. Now what we want to do is, let's try to increment the state every time we move. Okay, so first what we have to do is let's do something. Okay, let's if the state reaches state number 10, what do you call it? State number 9, sorry, we stop the program. So what we do is, let's, instead of an infinite loop, we'll have some constant over here. So let's say running is 1, halted is 0, machine state is 1 second. Hello. Okay, तो मेरे को WhatsApp कर देगा क्या? I'm kind of busy. Okay, so yeah, the running is 1, halted is 0, the machine state is running, yeah, of course. And what we do is, till machine state is equal to running. So this is more programmatic, I guess. And what we do then is if read write head. Okay, let's do it before the sleep. And you know, it's like Python, you have to be very careful with the indentation. So yeah, if I was thinking of writing, I wrote an extension for this actually. If you go on your VS Code and you search for this pilot extension, there would be an extension written by Aryan Kumar. I wrote that, and it apparently isn't working because there is some version issues. But yeah, I'll fix it later, and I'll put that up on GitHub, I guess. But whatever. If read write head is equal to 9, what we do is machine state is halted. Okay, so we don't want to mess with this. Okay, let's do this. Else, inside the else block, we'll increment let's simply increment it right now. Read write head is, we just want this to work. See, the thing is, I'm also not even sure if, of course, there are going to be some bugs in the compiler itself, and I'm not. I did spend an entire day working. There were some bugs. I did spend an entire day getting rid of them, but I'm pretty sure there must be more bugs. So I have to be careful by the way I write the code, because whatever. And inside the read write head also, we do this, and then let's over here outside the still, we do display in green. We do, let's call this machine halted. display dot green. One second. Machine halted and display dot green. What do we display in green? The machine output, right? So I think we got to write another output. Let's do machine halted at state number. Let's add state number, because when we actually write this, it won't halt always in that state number, but whatever. And display dot green. Let's do it like this. Tape output, and then let's make it inline, because after this we'll call the render tape function, and we have to create this first. So render tape. Okay, render tape exists, right? Render output, let's call it render output. Render output, render output, and then we have a function render output. Where do we write it? Let's write it over. Let's write it down here. Okay, let's write it at the top. Basically what it would do is it would range from 0 to 9 as index, and then it would do a display dot inline. See, it doesn't matter if you write green dot inline or inline dot green, doesn't matter. Both would mean the same. So it's very, I think this makes it very lenient in one sense, because there is no point in writing a logic that first you have to write green, first you have to write the color, then you have to write whether it is inline or not, because that means that's kind of, weird. You don't want to do that. I mean, that's what I thought. So yeah, and what we do is we get the tape, and then we write in the index. Let's put some space, and now let's try to run this. Let's see what's happening. So as you can see, the tape thing is incrementing, and this would stop on 9 if I'm not wrong. 7, 8, and it should stop now. And yeah, and the tape output is should I put a space? Let's not put a space actually. Let's just keep it like this. And what we'll do is let's call a new line over there itself, because even the cursor would be like, we have to write more functions over there. So okay, I mean, call new line 1, yeah. Now we have to wait for 9 seconds every time we run this, but we'll change that, doesn't matter. Okay, now over here, see, this is the reason why I created this function. Now if we want 3 spaces, we could just write that, and now this would give me 3 spaces. Now it's like I have to wait for 9 seconds, but yeah, at least I can see the output. And it didn't work great. I called new line 3, I passed in the new line counter, I ranged from this doesn't make any sense. Why? This should have given me more space. Let's try, I don't know, let's try 10. How did I mess up on a simple new line function? But it should work, I mean. Okay, let's do one thing I don't want to wait for. Let's just wait for 3 and then, okay. 1, 2, and 3. Okay, now it definitely works, okay. The thing is, I am too paranoid about my own code, so should I run this again? This would be very irritating for people to watch, but this for the last time, then we move to render the read-write thing. Yeah, it works. Great. And let's make it 2. I think I forgot to compile. I think that must be okay. This should work actually. 1 second. Okay. 1, 2, 3. Great. So whatever. So let's first put some initial state over here. So what we'll do is when the state is before we start, we call a function initialize tape. Yeah, let's call it that. And over here we have a function called as function initialize tape. what this would do is it would, let's initialize the tape, and let's say for every index that is either divisible by 3 or 5, we set that to be equal to 1. So what we do is we range from 1 2 3 4, we range for, we don't need to be 4, like any, we can have any value, but I'm just doing it for the sake of convention, trying to follow a convention. So range 0 to 9 as index, and if index, let's calculate two values, let's call it mod 1 with modulus 1 is index mod 3, modulus is too big, let's call it mod 2 is index times mod 5. The thing is, I implemented so many things, I forgot to implement logical operators like and or, and that would be very easy. Like if I just sit down for 3-4 hours, I could do that. But the thing is, I'm making this for my first year college project, and the submission is on Tuesday, and today is Sunday, right? Yeah, Sunday is gone. And the thing is, I just want to wrap. Of course, I didn't make this for my college project. That would be stupid. I make this because I made this because I wanted to make this, and I didn't care about the college project. I mean, you know, it's just happening in between. I anyways wanted to create this, so yeah. So, but anyways, the thing is, I have to submit this day after tomorrow. But after that, I have my college exams and stuff, and I don't really want to fail, so I have to study that. So that's why I'm not getting time for implementing more stuff. But implementing logical operators would be very easy. Like, you know, you could implement and or. The reason this is striking me right now is basically, now we have to write two if cases. Like if mod 1 is equal to 0, then we set the tape index to be equal to 1 is 1, even is equal to would work, but whatever. And we have to now write another like if statement, if mod 2 is equal to 0. If I had relational logical operators, sorry, I could have actually done that in one thing, but whatever. Now let's, okay, now let's call this and see. So yeah, as you can see over here, we have 1 0 0 and whatever. And now let's actually you know, let's add some colors to it. We had blue, we had cyan, we had yellow, we had green, we had purple. Okay, so what we'll do is let's do a simple if else. So if tape I is equal to 0, we'll display this. Else what we'll display is, we'll display dot inline tape I, and yeah, we have to add some color over here. This is for the case of 1, right? Let's call this red, and let's call this blue. Would that look weird? Oh, okay, I forgot. I have to take care of that also, right? Okay, I can't just... Okay, what we'll do is we'll just add this to the new line. And I have to do it on both of the cases. See, because this is in the same display statement, this also gets the color, and we don't want that to happen. So what we'll do is we just display dot inline without any color, and we display this, and we get rid of this comma. And again, for this also, we gotta do... Oh, 1 second. Yeah, we gotta do display dot inline, and yeah, let's try to run this. Cool. So now we have something great. Now we wanna actually you know, render the read write head. Like if I just do, I had this thing, right, box, yeah. So I wanna render this thing. So what we'll do is I'm going to create a function called as left padding that would left pad, like, you know, if this is over here, this entire thing has to be over here. So we have to add some left padding. So what we'll do is we have a function new line, and similarly, okay, we have to add some space over here. This would look better. And then over here, we have a function left padding, and we'll call it padding value. I guess what we'll do is we'll just display inline. You know what, there is like very similar to Python. I implemented this, like if you have a string, let's say hello, you could just do times 5 or times a value variable, whatever, it would display it that times. We could also use this operator, but whatever. So what we do is we display, we do an inline display of white space, and we do it padding value times. Very simple function. So now we gotta add another function which is called as render, what do you call it, render head. So we'll just call it function I misspelled function render head, which would take in the left offset. Then what we'll do is I think if I just go back over here, if the value of offset is 0, basically it's the index, right? It's the index, right? If the index is 1, this has to be over here. So there would be 4. So for every index, there must be a value of offset times 4. Like for every index, the offset must be times 4 of that. So what we do is we 1, 2, 3, 4 calculated. Okay, not left offset, or let's call it head offset. And let's call it left offset is head offset times 4. What we'll do then is display let's do okay. I'm kind of confused. How do we, like, it's very easy to implement, but I just want to have the most like, let's just write it, doesn't matter. I could have just done this over here. I didn't need to call the padding function, but let's do it anyways. Yeah. So let's call left. It would help later, like maybe if we add more things, but whatever. Left padding, left offset, and then we display yeah, we can just display 1, 2, 3, 4, 5. Again, we call the left padding, and we supply in the left offset, and then we display read write head. Cool. Should I use this instead of this? Okay, let's see. Why am I doing it like this? Yeah. Now we want to call the render head every time. So we render the tape, then we call the render head, and we supply in the head state. Now let's see. Okay, first of all, this has to be, let's make this 9 again, and this was inline, right? Okay, we got a call. Oh, I have to call the new line over here because because that would be on the print line itself, because this would be good. Yeah, so we have this now. So I want to change the colors. I mean, I'll do it later. I think I have more things to focus right now. Okay, but first let's actually make this square braces. This is a very simple video. I don't know why this is so long, and I haven't even done the main stuff, like writing the dictionary, but whatever. So we have this now, and okay, now see, it lags sometimes, but whatever, we have this. And now let's actually change the colors. We had cyan, right? I think I'll put cyan over here. Yeah. let's try purple. Or let's make this to be cyan, and where did it go? Let's make this to be cyan, this to be yellow, this to be yellow, and in the case of blue and red, right? Let's not do blue, let's do purple. I think I had purple. Yeah, let's see how this looks. This looks very bad. Doesn't go very well, right? Let's do one thing. Let's if it is 0, right, we just output it in white color. See, now this is better. Just 1 second, guys. I have to take this call. Just 1 second. Yeah, so I'm sorry, I had a call. My father called me, so whatever. So we have this. Yeah, this looks much better. This looks kind of minimalistic, I think, in a sense, but whatever. How I had more colors, man. Like, I want to add a color to this. Should I do it? I think I want to add a color to this. I could add green, blue. Let's add blue to it. Okay, we could add purple to it. We could definitely add purple to it. So let's try doing. Okay. What is wrong with Vim, I swear? Why do I use Vim? Display dot purple. And what we'll do is display. Okay, this is the final thing. Then I actually work on the Turing machine simulator. This must be very irritating for people to watch, but I'm sorry. I'm just printing some colors, and then this has to be inline 2. This has to be. I'm such an idiot. I could have done it on the same line. I thought I was, I thought I was working on, what do you say, the background also, but I'm not actually changing the background. I could have done this on one line. I'm an idiot, but okay, whatever. Okay, now this doesn't. Okay, I forgot to write. We don't need this to be inline again, right? We just. Yeah. See, now this is good enough for the UI, if you may call it, is good enough. I am having thoughts of changing the border color, but I know most of you would just dislike the video at this point. So I'll just move ahead with what we want to construct. So now I want to create a state dictionary. So what exactly, what happens is, see, let's say I'm reading out of state number 9. Our program is halting at state number 9. But what happens is, when we read out of a state, now, there are actually there is a dictionary. And for every state, we would have 4 parameters. So first I would define the dictionary. So state dictionary is 4 times 10, and the value would be 0. Let's like the initial value is 0. What happens is we have 10 states, right? For every state we have 4 columns, right? And this is basically how we write a comment. So the first value of the column would be the value we read out of the state. So that would be the case. Then we would have the right value, what we would write in that case. Then we would have the shift value where we would shift. Then we have the state jump value, the new state which we would follow. So let's write a function. Let's write a function to first initialize render the state dictionary. Like we have render head. Let's write a function to render state dictionary. And we have we can just call it over here, I guess. Yeah. Render state dictionary. Now what we want is we want to have first thing is I want to add a arrow like this. So we want to have a padding, but I'll do it later. I'll do the padding part later. I'll just simply first do on display, and what we'll display is yeah, the case, the write value, the read value. Okay, no, what? Case, write, shift, state. Yeah, sorry. Case value, the write value, the shift value, and the state value. Cool. What we'll do then is we'll just display. Okay, we have to range in this 2D array, right? If you saw 0 to 3 and 0 to 9, so we range from 0 to 3 as I, and then inside this we call the new line, and we range from 0 to 9 as j, if I'm not wrong, and then inside that what we'll do is we display dot inline, and we display the state dictionary I j, and then we also add some space then. Okay, let's see, this should give me something. Yeah, the spacing thing is, there shouldn't be so many numbers. What's wrong? Oh, I messed up. I think I messed up the. Did I mess up this thing, or did I implement this wrong in the compiler itself? 1 second. Because 4 times this. Oh no. This has to be like this. I think this has to be like this. I think so. Okay, no, what the hell? Oh, I messed up the dimensions. What's wrong with me? It has to be 10 times 4, right? 4 times 10 means 4 rows and 10 columns. We want 10 columns and 4 rows. See, the thing is, when I do something wrong programmatically, like make a logical error, my first thought is, did I make some error in the compiler? Is there some bug? Is there some bug in the compiler? And that is, trust me, very petrifying. So yeah, and actually this should be fine. And this, yeah, so we have something on the screen. Cool. And we want to add some more space to it, and I could just do times. Why am I implemented a feature, I'm not using it? Let's call it 5. Wow, okay, we have to, let's call it 8 times. I'm sorry for the trial and error that I'm doing in this video, but yeah, see, perfect in the sense that let's do one thing. Let's call it 6 times and add some spacing at the start, like 2 spacing at the start, and that would be symmetrical. Okay, it isn't symmetrical. Don't worry, we can just remove 1 at the end. That would be good enough if I'm not wrong. Whatever, I don't care. So we have something. We have the case and this and this and this, right? So what we'll do is we want to add, I first make this table look better? See, this video would also consist of making stuff look better on the screen. So that's going to be kind of irritating for some people, but I'm sorry. So we have this. Let's add a padding. Let's add a left padding. Let's make it a bit smaller. Yeah, let's add a left padding first. What we could do is we could also display this Okay, now I actually want to add some space over here. So what we'll do is 1, 2, 3, 4, 5, 6. 6 would be good, right? But it has to be odd number. 7. Cool. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. Okay, my mind is kind of blank right now. I don't know why, but 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5, 6, 7. Doesn't matter, we'll adjust it. Cool. Now we have this. Okay, so what we wanna do is I wanna add some kind of but then okay, I wanna have consistent spacing over here. So 1, 2, 3, 4, 5, 6. We get the maximum spacing first. 1, 2, 3, 4, 5, 6, 7. I think that's the one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Cool. And we'll just add some space over here. What we'll do then is 7. So we render this like this, and we render this, and let's see, this should work. Like this should work in the sense this should be good enough. Okay, now I get the point. I get what happened. So what I'll do is I'll just I'll do display dot inline that should be good enough. And I think I need to add some spaces. I think if I add one space on each of the side, that would be good enough. So 1 and 1 should take care of it. Cool. And I have to just add this, and then we'll be good enough. Cool, we have this. Now what I want to do is okay, I want to shift everything by a left padding of this is 1, 2, 3. Okay, let's go to box.py. Like if I do vim box.py, I want to render an arrow. So what should be the size? Let's do 1, 2, and 3, or let's do 1, 2, 3, and 4, and then space. I don't need to call the left. Okay, I don't need to call the left padding function. Which one looks better actually? I think this would be too small. So, and yeah, so let's do 3 and this whatever. Yeah. Why do I go out of this thing? I'm recording, right? It would be funny if I didn't enable my mic again, but whatever. So what we'll do is we'll shift. Okay, the padding would be then 1, 2, 3, 4, and then 1 second, space. Cool. So 1, 2, 3, 4, 5. So what we'll do is we will do called left padding 5. Then again we will left padding 5, and then okay, we wanna also have access to the state, right? So we'll pass it over here, the head state. So we'll pass it the head state over here. See, this is gonna be good looking, I think. I think from my perspective, like my standards are very low, so from that it would be good looking. So head state, if I'm, let's call it head state again, shouldn't be an issue. And what we do is if I is equal to, let's call it current head state. If I is equal to current head state, what we'll do is 1 2 3 4, we'll display 1 2 3 4 5 inline. I'm sorry, it has to be inline, else we'll display else we'll just call the padding, right? And we pass in 5. Yeah, let's see if this works or not. See, we have something. So at least it's kind of looks good. What we could do is, now we could actually add background color, like make it green. Should we do it? Okay, let's do that also. And what we'll do then is, okay, we'll just, what we do is, let's do let's make this yellow, and display dot inline over here would then be green. And else we would do this, and over here if I is equal to, again we make that check. Not the best way to do it, but I'll just do this anyways. This would be the else clause, right? Else we do this. 1 2 3 4. 1 2 3 4. We do display dot inline dot green, and I think this should be good enough. And it would crash. Okay, that's weird. Pilot tube token dot. Okay, I didn't compile it, and I messed up. Yeah. What the hell? Yeah. Let's see, this should work. I messed up the spacing, and 1 2 3 1 2 3 1 2, everything seems okay. There is some extra space over here. Yeah. Should I make the background color itself to be green? Let's try that. Just add the background tag over here. Over here also we could do background. Yeah, this looks much better, right? Yeah, this looks much better. And we'll just call the new line over here also, like, uh, one second. Should I call it once or twice? One looks good. I hope the video wasn't lagging. I genuinely hope that. See, now we have this thing, so yeah. I'll make this white. This is kind of unnecessary and standing out a bit, so yeah. Okay, the thing is, how many colors do I actually have? I don't even remember. Let's do. We have purple, cyan. Do we have black? Can we make it black? If I remember, there was some issue in the black thing, so let's try it. Let's try it. Okay, this isn't black, obviously, so there is some issue in the black, some issue with the, what do you call it? Uh, the ASCII codes, not the ASCII codes, the ANSI color codes, but whatever. Instead of black, we could go with a different color, right? Let's make it yellow. Let's just make it yellow. Let's make it purple. The thing is, purple, because the read write head is also purple, so yeah. See, it is more kind of consistent now. Should I also make this purple? What the hell is genuinely wrong with Vim? Okay, if I don't click on insert mode, anything could happen. Cool. At least we have something, right? Now, this is good enough. Good enough. So, what we want to do now is we want to actually initialize the state with something. So, what we'll do is we call the initialize state method. We'll call the initialize state dictionary method, and we have okay, now my video would be lagging terribly because the power is cut and my laptop is now not plugged in, so I apologize for that, and I think that would be max to max for 2 minutes, so I'll just cut this part out if possible. This is at 54 minutes, so hi guys. So I think that was 1 minute of delay. I'm so sorry. normally in my hostel the power isn't cut, but the thing is I'm running this laptop is terribly slow because I have millions of softwares, and apart from that I'm running OBS, and apart from that I'm running a Linux instance on virtual machine, so it would be lagging if I don't plug it in. So yeah, whatever. Coming back to what we were doing, we were initializing a function called as initialize. What was it called? I think I want to get rid of this first, and yeah, initialize state dictionary. So dictionary. What we'll do over here is we want to initialize. Okay, we had this right. Let's case. The case would either be uh, 0 or 1, and again the right would also be 0 and 1. The shift would also be 0 and 1, and depending on the shift value we'll actually do the changes, but whatever. So what we'll do is we first initialize the case. Okay, the case. Okay, damn, I made a very stupid error. The case would be two values, right? The case could either be 0 or 1. Okay, now that's a very stupid mistake. Okay, so what we'll do then is I gotta find a way to see if we move to the state number, the case can be 0 or 1, right? Okay, we'll deal with that. Don't worry. Let's just populate the first three columns with some logic. Let's make it random. I don't care. So not random in the sense that let's make the first column. Let's for every alternate value, let's make it 0 and 1. So what we'll do is first we want to range from 0 to 9 as index. That's the first. And what we'll do is the 0th column would be the state 1 2 3 4. The case column is 0. Right column is 1. Shift column is 2, and state column is 3. Cool. First we calculate some stuff. Okay, first we calculate mod is even. Okay, let's do mod 1 is. Let's calculate some modulus values, and upon that we'll do the casing and stuff. So mod 1 is tape index times 2. Mod 2 is tape index times 3. Mod 3 is tape index times, I don't know, 5, I guess, and mod. Okay, why do I, let's call it mod 2, mod 3, mod 5, and mod 7. Mod 7 would only be 1. Mod 4, let's call it mod 4. Yeah, so we have 2 3 1 2 3 4. Yeah, we have mod 4 is tape index modulus 4. Cool. So first, writing to the case column, if mod 2 is equal to 0, we just simply write a 1 to it. Yeah. So how do we do it actually? We get the index, right? Yeah. So we have state dictionary case column, and what do you call it, index, if I'm not wrong. Index is 1. Let's see if this is working. An unexpected token math. I can't use, I forgot, I can't, like this is a compiler issue because I can't actually use math with array sub-array values because I know how to do it, but I didn't implement this of right now, but whatever. So let's call it current value. Current value is tape index, and we'll just write this with current value. See, this is the reason I probably should switch from Vim, but I can't use something like VS Code. First of all, because I don't want to, and secondly, the thing with VS Code is it would take a lot of RAM, and my OBS would be terribly slow then. So yeah. Okay, not like this. Sorry. Yeah. So okay, I don't know what happened. I really don't know what happened. Case column index is 1. Yeah. Case column is 0, right? Oh shit, I'm so sorry. This has to be index and case column. Again, the power is cut. So I'll actually just resume after the power is on, and that would be max to max 2 minutes. I'm sorry. Yeah, so the power is back. Yeah. So this has to be index and then the case column. So yeah, but still, why the hell is this is 0, 1, 2? This doesn't make any sense at all. If mod 2 is 0, this should be alternating, right? Okay, this is weird. For 0, for 1, and that's the problem with writing stuff. Like, you don't know if it's a compiler error or it's your error, but whatever. I think it's my, like, this current program error, but whatever. What the hell? Should I just sleep every second for this? But okay, let's just do it. I'm just debugging this kind of. Oh shit, I am so sorry. Damn, I am such an idiot. We take the index. We don't switch on the value at that index. I mean, I don't know what's wrong with me. And for that case, we could actually just mod on the index, but I'm so sorry. What a stupid error. And is my mic on? Yeah. That would be more stupider, but thank God actually I'm checking the stuff I write, because I'm used to writing terrible code. So I have to check what I'm writing every time. this should be good enough. Yeah, as you can see now we have 1 0 1 0 1 0 blah blah blah. Let's do one thing. Let's make this to be in the right column, because we don't know what we're going to do with the case column, because there are supposed to be two cases. Or should we just get rid of the case column itself? I know, like talking about Turing machines, busy we were Turing machines, we are supposed to have two cases. Depending on what we read, we actually write stuff down. But the thing is, I could do it, obviously, right? It would just be, but let's not be lethargic. Maybe I'll write it down. Let's see what happens. But let's first let's do something. So so let's work on the shift thing. So if it is 3 and 4, let's do 3 and 4 would be, yeah, let's do 3 and 4. So if mod 3 is equal to 0 and if mod 4 is equal to 0, state dictionary index, let's call it shift column is 1, and now let's run this. Okay, what the hell? Oh, what the hell? Because this has to be in separate. Something is wrong with me today. Like if mod 3, or I implemented mod 3 and mod 4, that's why only the first thing, which was 0, I guess that only happened. Shift. Yeah, and 1 2 3 1 2 3 4. Let's keep it 4. Yeah. There you go. Dictionary. I was thinking there is some typo, but 1 second. Dictionary. Yeah. So we have something now. Cool. Let's do one thing. Let's actually switch on the basis of the state. So now we have to populate the state values, right? How do we populate the state values? Should we put random numbers? But we just can't. I haven't written. See, I was thinking of writing my own random number generator. Like I think in java.util.random we have it implements under the hood, what do you call it, LCG, linear congruential generator. It's a very simple linear algorithm which takes in the seed value, and I think the algorithm is xn plus 1 is equal to a naught xn plus c modulus 5 something modulus m something. So we have that, and I think in C++ we have XOR shift 128, and we also have linear feedback shift register LFSR. I was thinking of writing my own random number generator, and the way I actually did some research about this, and what actually I found, the idea is that we use the property of irrational numbers like e or pi. Like I had pi in my mind, and basically pi, there is this formula, I think it's called the what's it called, Bailey-Berlin-Plouffe formula, which basically is a summation formula which k is equal to 0 to infinity 1 by 16 to the power of k something, some fractional things, and depending on the value of k, it would render the precise digits of pi. Like if the value of k is something like, let's say 10, it would render the first 10 digits of pi and something like that. So what I thought of is I could take in the starting time, whenever we start the program, the seed value would be the current epoch time, and the way we do it in assembly is we just move to the RAX register 201, we XOR the RDI register, and then we make a syscall, and then the value, the epoch time, would be in the RAX register. So that would be something like 1783, something like this, and it would be updated every second, obviously. So depending on this, we could take this to be the seed value, and then we could we would take this, we would divide this by some value. So let's say we would take in the last 4 digits, so we would have 9439. So that would be the starting offset, and from this starting offset we would get the next digits of pi, and that is, I think, the digits of pi as of now is random. That's why we call it irrational, I guess, but whatever. So I thought of doing this, and I did write a pseudo code of this in Python. That worked up till 10,000. That worked up till 10,000. Apart, then after that, it took a lot of time. Like I don't even remember. I think it worked up till 5,000. But whatever, the period was very small. But the thing is, I would have implemented this anyways, even if the period is small. Like, doesn't matter. I'm doing it for the sake of doing it. So maybe in the future videos, if I have some time, I would do it. It's very interesting. I find this very interesting, but whatever. Coming back to the topic of mod 2, mod 3, mod 4, how do we fill in the state values? Let's do if mod 5 is equal to if mod 2, if mod 3 is equal to 0, let's say, and let's get rid of this. Writing if mod 3 is equal to 0, let's do state dictionary index state column is, should I put index plus 1? Let's do this for mod is 2 is equal to 0. So now we would have some initialized values, right? Cool, we have this. Yeah, we can keep doing something like this. So yeah, at least I have something in my mind right now. So if mod 5 is equal to 0, let's say, let's do state dictionary index state column is, let's do index by 3, or let's make it by 2. Let's see what happens now. Okay, now this is weird. Let's make it by 3, but the thing is, what happened, why is index by 3 also? What if I make it index by 10? Did I not implement this functionality? I think I did implement this, but there's something wrong with this. Wait. Cool. What I'll do is I'll get rid of this. 1 second. This is weird. It was mod 2, right? Okay. Wait. Why did I change it? Yeah, this is good. And now for the case of if it is mod 5, what we'll do is we'll do state dictionary index state column is indexed by 2. Now let's see what happens. Okay, let's call it index minus 1. I don't know what's wrong with division, but division does work. But okay, now we have this then. Okay, let's make this at the top. Okay, I'll actually open this in mousepad. So what you want to do is you want to actually I hope this doesn't mess up with the program. The thing is, the prime numbers are getting left behind, right? For prime numbers, mod 3 we have. Okay, let's just simply write them down, like if index is equal to 1, state I'm actually regretting writing this function altogether because I could have done this in better manner, but whatever. Dictionary is, let's call it 1 itself. Okay, that would be self-referential and that would lead to a loop. We don't want that. Actually, I actually forgot to check this altogether. So 1, this is the 0th state, right? 0, 1, 2, 3, 3, 7 and 9 are remaining if I'm not wrong. So let's write something for 3, and for 3 we'll subtract this by 1. Let's say index plus minus 1. Let's save it, let's run it. Okay, mod 3, I'm sorry, let's do it. If 3, 4, 5 mod 3 is equal to, yeah, and then we gotta write overwrite the 0th state. State column, yeah. Let's write it to be, I don't know, 7, let's say. I'm sorry. See, at least the error thing works, so. Now we have 1 and we have, what is it? 1, 2, 3, 4, 5, 6, 7. 7, 1 and 7. Right, cool. For the case of 1, we could put it to 4, let's say. Could just copy this, like why am I writing this again? For the case of 1 we put this to 4, let's say, and for the case of 7 we put this to 3. We already have 3. Okay, we put this 0. We gotta have some place 0 also, right? But then 7 is 0 and 0 is 7, so that would be a loop. So let's put this to be 7 and this to be 0. Yeah, let's see what happens then. We have 2 7s. We don't have a 1 anywhere. 1, 2, 3, 4. Should I make this 1? Would that be... Okay, now this is editing this thing, right? This was 7. Let's make this one. I think it is balanced now. 1, 2, 3, 4, 5. Okay, 6 should be over here. 0, 1, 2, 3, 4. Let's make index 4 to be equal to 6. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. Now we gotta implement the case thing, right? Because what's the point of writing if you're not implementing that? So whatever. So yeah, we want to have a global variable. Let's make it. The thing is, let's call it current dictionary, and let's let this be equal to 0. Read out of 0, right? Cool. We read out of 0, and over here what we want is, else what we want is we also want to write the data over there, right? Cool. So read write data is actually state. One second. State dictionary index. Let's call it dictionary index. State dictionary, dictionary index, and state column. Cool. State column is undefined. Cool. 0, 1, 2, 3, 3. That should be good enough. Why? Why is this happening? I can't see exactly what, like, how is it jumping? Jumping to state 7. Should we print this? Let's call it display.read. State number 7, and why is the value of this? I forgot to implement this, right? I'm so sorry. After this we want to change the dictionary index also, right? So dictionary dictionary index is let's do one thing. We have to get the value of shift, right? Okay, this is actually kind of confusing. I thought this would be very easy. I don't know why I'm so confused. Jump to state number. Okay, this and this are, I think, kind of unrelated, I guess. Let's call it card then, I guess. I'm not really sure. Okay, we'll do this later actually. How is this so actually uh like it's very easy to implement, but I don't know what's wrong with me. Uh, so if we have, let's say we are reading this, we jump to this, and then we change this. So this is exact. Let's call this. What do we call? Okay, we'll change the name later. Let's. Okay, this dictionary index is. Should we do this? This should take care of it. Let's see. Okay, I don't know what the hell happened. 1 second. Okay, we have a loop. I think depending on this, we could change the value, right? Cool. What we'll do is, let's just make this. Okay, 1 second. How long is this video? Oh, not that long. Great. I think this would be wrapped up under 2 minutes. We're going to be doing the entire thing. I don't care. I'll do the case thing also. Let's just start with a different state, I guess. 5, let's say. Okay, damn, this is actually very terrible. The thing is, if we add more states to it, and let's add the let's add the changing thing also, like when we write this, right? So when we render, when we do this, what we do is we do tape read write head is state dictionary index and uh 1, if I'm not wrong. This would be 1. Cool. Now we would get some changes in the tape. Why the hell is this so slow? No, it's not happening. Why is it not happening? 0 1, we get the value, right? Display writing this to the 1 second. Why is this stuck? Why is this 0? Okay, but why isn't the right operation happening then? I mean, it is being printed over there also, but I don't know what's. Again, I'm not sure if this is a compiler thing or. Zero, 1, 2, 3, 4, 5. Oh, okay. Let's change the value. Let's do it. Can we do -1? Let's make this to be I don't know 6. Let's 6 would then again loop. Let's make this 3. Okay, let's do 0, 1, 2. Let's try to manually switch this to 2 and let's see if that's working. 2, 2, 2, 2, 2. Let's do tape 2 is 1. Let's see if this is working or not. This is working. Okay, this is actually kind of confusing now. Should have done this in Python first, but okay. Jumping to state number this. Thing is, it's almost implemented. I just want to get the final thing down. So, okay, let's just. Let's try to write 0. Let's see what's happening. Let's try to override this with 0. Let's see. I think I know what's happening. Okay. I think it is stuck in a loop. Otherwise, the thing is working properly. Cool. Let's actually completely detach this. Let's implement the case thing, right? Uh, uh, should I do it like this or? So we have to make two dictionaries now, right? We have to make one for case 0 and case 1. Yeah, let's do it. Doesn't matter. 3. This would be very terrible to refactor. Refactor. 1. Cool. Initialize state dictionary 0, let's say. We don't want to mess with the case column. Right column is 0, 0, 1, 2. Cool. Now this is good enough. So we initialize both of the state dictionaries, right? We initialize dictionary 0. If anyone who's genuinely watching this, I am so sorry for this terrible video. I didn't know this would be. This is very easy. The thing is, I'm not a good programmer, I guess, so I don't know how to do it. And the thing is, I'm doing it in my own language, so I think there is one also boundary over there. But whatever. Let's copy this function. I have this very, very, very strong feeling that I'm over-engineering this. This doesn't have to be so difficult. And I'm pretty sure that's true, but let's change this to be 3, let's change this to be 2, let's change this to be 5, let's change this to be 3, 2, 5, and let's call this 7016. Damn. Numlock is genuinely one of the worst things ever invented. 7016 0174. 0174 7016 7016. Cool. Now what we do now is we have these two things and you have to render the dictionary, right? New line, we do a left padding, we do case, let's just do it for 0 first and let's see. Debugging this would be very hard because 1 second, where am I making changes? Oh, okay, let's make it 0 for now, everything to be equal to 0. Okay, 2002. Cool. Where are we referencing state dictionary again? Let me just check. We'll do it, guys. In this video we'll actually do it. I don't care how long this takes, but we're gonna be doing this. Where are we actually referencing this again? I don't know. "28 occurrences, really?" Okay, let's just see. 0 0 0 0 0 0. Okay, over here. Damn it, I have to now implement this over here. Let's just do it like this. So 1 2. Okay, now let's see. We have more things. Oh, I forgot I had to. Okay, I'll just copy this. Don't worry. 1 1 1. see. It is stuck. Okay. Oh, it's not stuck. Okay. Yeah, it doesn't matter. We have something. So we want to get rid of the case thing. So how are we actually still getting this? We don't want the case thing. Okay, what? Wait. 1, 2, 3, 4, 5, 6, 7, 8. 8, right? So 13. This has to be 13. Put this 13. 1, 2, 3, 4, 5, 6, 7, 8, and 13. Let's see. Okay, now this. Why the hell did I increase the padding? What's wrong with me? I could have just made this 5, right? Something is wrong with me. But 5, and then we have this. Cool, we have this. So and of course we got a now 9, and then this would be this would be 2 if I'm not wrong. So let's clear this Turing, and yeah, we have this. So yeah, okay. Now let's kind of how many, like 1, 2, 3, like around 9. 1, 2, 3, 4, 5, 6. Okay, we have this over here. Cool. You know, actually what we could do case 0. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is 13 again. Okay, let's try this. What's the worst that could happen? One, and then let's say 6 and 7 would do, right? Yeah. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Let's try this. Okay. Oh, why am I calling the padding here? We don't need to call the padding then. And then 3, I guess. So 1, 2, 3. 1, 2, and let's add. Kind of brute forcing at this point, but cool. Cool. So yeah, I think we are on the right track now. I just have to get this a bit smaller. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Should I make this smaller? Should I make this bigger and then 1 from here? Yeah, this makes more sense, right? Wait. 1, 2, 3, 4. 1, 2, 3, 4. Okay, I have to get rid. Yeah, this should be good. This should be good enough. Great. So yeah, we have this now. We write the other state, like the corresponding thing, for the case 2. Cool. I want to change this number. Let's change this from red to uh, cyan, I guess. Let's make it cyan, yeah. So where did I have this render tape? Right here. Let's make it 1 2 3 cyan. And now, before doing this, what we'll do is we'll do display dot. Okay, before this, I need to calculate the total number of pixels. So 1 2. I can't do that. Can I just copy this? And if I just paste this here, I already have this, so whatever. Yeah. So 1 2 3 4 5 6 7 8 9 10 11 12 13. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 25 and 13 is 38. So we want to have a call. Should I do a call left padding? But we want to subtract this, right? So 25. 38 minus 13 is 25. So we want to call padding, left padding of 25 if I'm not wrong, because we only want. Okay, we don't even. What the hell is wrong with me? We don't even need to do that. We just want to have some space. So let's call padding of 5. And we copy this and paste this, and this would be for case number 1. Let's see how it turns out to be. Cool. Okay, we have to make space for this though, right? That, how many pixels does this involve? 2 3 4 5 6 7 8 9 10 11 12 13. Okay, so normally we'll do a padding of 13. So okay, we have to call a left padding of. Oh, is it good enough? I think it's good enough. Okay, so what we'll do is we'll do display. We'll call the new line if I'm not wrong, and let's do this. I want this to be down, so let's do display. Let's do call new line 1. That will get this down. We display this. We do an inline display. We call left padding. Let's call it 13 if I'm not wrong, and then we just call this again. Okay, this messed up the entire thing. Oh, I forgot we had to call. Okay, first. I forgot. So this doesn't have to be first of all inline. This could be display. Then this had to have a padding of whatever this is. So 1 2 3 4 5 6 7 8 9 10 11 12 13. Of course, this had to be 13. I forgot to write that. So 13 and 13. Yeah, this makes more sense logically also. And if it doesn't work after saying that, that would be embarrassing. So I hope it works, and kind of did work. So we had to account for this also, right? So 1 2 1 second 1 2 hey, 1, 2, 3, 4, 5, if I'm not wrong. So 18. So and then we would have this. So yeah, we have something at least. So cool. Now what we want to do is, so this would be very ugly now. This would be very ugly. Like what I'm about to do. I want to do conditional printing and stuff. So okay, what we'll do is we have to calculate the total thing now first. What's the total? This is 18 if I'm not wrong. So at a padding of 18, we'll print the details of this. So if we print this current head state, yeah, I'll fix this. If I is equal to current head. Okay, what we'll do, okay, this is actually very easy. Actually, we'll just call the left padding of 18, and what we'll do then is we'll call the inline 1 or state 1, yeah, and we just do this again. We call the left padding of 18 we read from 1 dictionary. Cool. So let's see what this gives us. Okay, I don't want this to happen. Okay, so what is exactly happening? Okay, I can't do it. Oh, I forgot. So I have to loop twice. What we'll do is we'll do range 0 to 1 as current dictionary, let's say. Damn, you know what I could have done is I could have wrapped this in one. See, this is the reason I'm so stupid. I could have wrapped this in one 3D array and could have made this 2. Should I do it now again? This would be very like practical also. I want to do it like this, so yeah, I'll do it like this. Doesn't matter. I don't care. I'm sorry for anyone who, you could actually dislike this video. This video is actually so terrible, but what we'll do is we'll take in the dictionary. Let's call it the first dimension. Take in the first dimension. We'll call it twice, so that's how we'll get it. And the first dimension, we just pass this here. So state dictionary. Should I take it? Okay, 1 second. First dimension, and we paste this everywhere, and we'll get, see, this would make our code better. So that's the pro, I guess. I don't know. 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 and 1 2. Cool. We have this now. The thing is, oh, fuck, I forgot. Now we have 2 dictionaries, right? Okay, we'll call it we'll call it 0 and 1, and we'll pass in the dimension, and yeah, we'll call it depending on the dimension itself. So it would work, don't worry, it would work. So actually that doesn't get rid of the code. The code is still cluttered, but still, at least we get less one array. I don't know how that is beneficial, but See, I'm limited by the capabilities of my own terrible language, so I think you have to account for that also, but whatever. Yeah. Now we have this. How long is it? It has been 2 hours, right? Approximately 2 hours. I think it would be done in 2.5 hours, I guess. Okay. So initialize, what we'll do is, actually let's, this would be 0 itself, right? We don't need to do it like this, so we'll just put 0 over here, and for that case we'll put 1, 2, 3, and finally, and we don't need this, and then we want to put 1 over here. So 1, 1, 1, 1, 1, and 1 here, and 1 here, and 1 here, and 1 here. Cool. And we have this render tape is working, render state dictionary. Cool. Now we have to implement some things over here. Yeah, I think that this wouldn't be much of an issue, because yeah, I have to fix stuff over here, that's the thing. So let's call it 0. Let's replace this with 0. Let's, for the sake of it right now. And while initializing also I gotta do that, but okay, 1 second. Should have write this down this manually, but whatever. Yeah, I think this is good over here. Let's get rid of this. So we are initializing the first and the second. Let's actually call the initialize state dictionary, and the initialize state dictionary would be a wrapper function which would call these two functions. So I like this way better. So one, two, three, four, 1, 2, 3, 4, and the end is 0. Cool. Yeah, great. So we have this, and now I think we just gotta change this thing. What do you call it? See, we are about to be done. Like within half an hour we'll be done, and it's still sunlight outside, so it's good. Yeah. So over here, what we do is, let's go. Yeah. So this is good. See, this is another, a beauty of not my language, indent based languages in general. So you had this, right? We added the statement, right? We didn't have this before. We added this, right? We typed in range 0 to 1 as current dictionary. Now what we had to do with bracket based language is what we could also wrap that, like wrap braces around that. That wouldn't be an issue, so not much of a deal. But yeah, 2 spaces fixed this, so whatever. Okay, but we can't do it like this also. Like we did wrap it around this, but I think for every yeah, we could try to do it like this. Wait, we make this inside, and phi is equal to current head state, let's call left padding. Oh, I think I got it, I guess. And we could supply current dictionary over here. I write such terrible code, I'm so sorry. Yeah. And we don't need this. We don't need this, if I'm not wrong. We can do. Oh shit, one second. Didn't even press delete. What's wrong with. What the hell? Okay, I'll not do that. Else, we have this. We call left padding and we call new line. Let's see. It wouldn't work. Most probably, but what the hell? That's surprising. And we actually get different values at least, but how is it so butchered? Like, wait, what is happening? I need to fix this first. So we are iterating for every head. Yeah, and oh shit, this has to be uh 1 2 1 2. No, it doesn't have to be here. What the hell is wrong with me? Okay, let's try this. At least that compiled, I mean. How is this more organized? What the fuck? Okay, we have something. That's cool. This has to be here and okay. Damn it, this is kind of weird. Let's first get rid of these two statements. This is kind of irritating. Turing, cool. Okay, so this is the 13 padding if I'm not wrong, right? First of all, the values are, see, the values are different, so we are getting some. Okay, wait. Oh, I think I know what happened. The pairing got wrong. Yeah, we're supposed to render for every three thing. We are supposed to render. Okay, now this is irritating because we are supposed to get this here. Okay, so what we'll do is, I know what's happening. We are rendering this through the. I get it. So, but how do we fix this now? Next very try. Okay, so but then that would. Okay, let's do one thing. We don't do it like this. We have one loop. Let's get rid of this. Cool, we do this. Why the hell is this happening? So irritating. Now if I do this, still happening, damn. Cool, I'll not mess with this. Okay, so first we print out the details of the first row. Then current dictionary is 1. No, but this wouldn't fix anything. Okay, this is actually so confusing. This is okay. Now I get the picture of what's happening, I guess. I think I've said this like 10 times, but over here we loop outside of it. So range, let's do 0 to 1 as current dictionary. Inside this we render stuff. Can I get rid of this now? Thank God. Okay, we render stuff. So should I just 1 2 1 2 1 2 1 2 and 1 2? Cool. So we are rendering this. After this render, we call the left padding of the size would be 1 2 3 4 5 6 7 13 if I'm not wrong. We did this before also, right? Let's get rid of this and let's see what happens now. Yeah, let's see what happens. Cool, we have something. That's great. Okay, so we have something. Now what we want to do is we want to first of all we want to fix this value. So in the second dictionary, the 9th index, we have repeated 4s, right? We have 4 repeated twice, so we make the 4 to be equal to 2 is not there. If I'm not 2 is not, we will make this to be equal to 2, and if index is equal to 9, what we'll do is 2 and let's make it 9. Let's also make what else do we have repeated? We have 1 repeated. Let's make this to be equal to 9 again, because 9 is our halting state, right? So we want that to be cool. Okay, we have something, and now what we want to do is okay, now what we want is we first want to fix. Okay, I think we'll be done. So I guess we'll be done. So what's the time? We'll be done by 2.5 hours, I guess. Writing a Turing machine should not take 2.5 hours. But it's my first time. I obviously knew what Turing machine was, and I know what Turing complete is. I know what the basics, not in depth also, but I know what the basics are. But this is my first time implementing this, and I'm implementing this first time in Pilot, which is an untested language, which I wrote as a hobby project. So I think that's the reason why this is being delayed so much. But whatever. So this is one. Actually, the fact that I wrote 180 lines of code in Pilot itself, actually, this makes me very happy. Legit makes me very happy, but whatever. Cool. We want to fix this first, so we add some padding and okay, now where is this? Over here, right? Yeah. Should I copy this entire thing? What is the worst that could happen? Oh no, we can't do that. Wait, I don't want to mess up what I just wrote, but yeah. Cut this and we paste this here. Cool. Pilot Turing.py. Yeah, over here we are getting double things, but and we want to increase the padding also, right? Cool, we'll do that. The padding has to be 18 if I'm not wrong, so because we are also accounting for that, so padding thing would be taken care of. And cool, so this is good, and I just want this double thing to be fixed. So how would we fix that? Ah, oh, that's why this is childish error, but oh, and now that's the thing. Now we can't. And inline, basically, okay. What we'll do is if I is equal to current head state 1 2 3 4 display dot inline dot purple, else we just do a simple display. Cool, now we would have that ready. Oh, it has to be background. The background has to be purple. Actually, even the purple color look nice. Should I make it purple, the color purple? No, it's okay. Cool, we have something. Okay. Okay, so what we'll do now, we'll jump, we'll just implement the functionality in which we'll jump between these two dictionaries, and depending upon that we'll render stuff. So cool. So we have a dictionary in what the hell is a dictionary index? When am I using this? 5 occurrences. What the hell? Oh, the start. Oh, hey Bhagwan. Why do I name it so weirdly? Dictionary index should actually be let's call it dictionary row. Dictionary, what do you call it? We have displayed the data onto the screen. Now we basically want to work with it, and that's going to be very easy, I think. I even said this about this video. I genuinely thought this video would be done in like half an hour. Let's call it dictionary ID maybe. Do we have current dictionary? We have current dictionary. Okay. Dictionary index. Let's call it dictionary index. Cool. Do we have dictionary index, by the way? We did. I mean, we rewrote it, so over there. Cool. I think it's over there if I'm not wrong. Cool, 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 cool. So, dictionary. We start with dictionary. We start with. Let's make it. We start with the first dictionary. Cool. So now, basically what we want, if the value of read write head is somehow 9, we halt the machine, and this would jump out of here and the tape output would be given. Else the read write head should be state dictionary index dictionary. We had a dictionary index and we had dictionary row, right? Yeah. Dictionary row. Okay, so 0, 1, 2. Okay, so cool. This thing should be actual. So confused. Dictionary row first of all. So you get the state. So, but this shouldn't be the state, right? I think the dictionary index Oh, so the dictionary row is, but then I think we have to use temporary, right? We use temporary. Let's make it caps. Temporary dictionary row is 0, 1, 2. That would give us the row, and the dictionary case would be given to us by temporary dictionary row. And what do we have? Dictionary index, I guess. Oh no, this would depend on the value which we extract. That would be the tape read write head. So tape read write head. Cool. Okay, this is kind of confusing. I don't even know what I'm doing. Temporary. We get the temporary dictionary row. We get the state. We get the value that we write. Okay, we first write the value. Okay. So after this, what we'll do is we'll write the value using tape read write head is. We will make use of all of the attributes. So that's the thing. 1. We write 1 and we shift Now if 0, okay, wait, this has to be 0, right? Yeah, and if one is equal to 0 is equal to 0, see, uh, this should be equal to 0, because see, what I want to say is actually is we don't want this. If it is 0, we'll go left, or -1. If it is 1, we go right or +1. So we have 1 over here, so we won't go out of bounds. We have 1 over here, we won't go out of bounds. We have 0 over here, we won't go out of bounds, but we have 1 over here. So you got to change this to 0. Cool. And I think that's in the first dictionary, and shift index, ninth, if I'm not wrong. Am I addressing index 9? No. Cool. Index 9, and state column is not state column, it's the shift column, if I'm not wrong. Right, yeah. And I write that value to be equal to 0. Cool. So we have that. Now we get the temporary row index. We get the temporary index. We remove this first. Tape retry head would be equal to the value stored in the 0. I have to 0 1 2. 0 is write value, 1 is shift value, 2 is row/state. I have to change the name though, but whatever. So from 2 we get the temporary row. Cool. From then we get the dictionary from the current whatever we read, and then we write the value 0, and then depending on whatever 1th row is. Yeah. So if this is equal to 0, read write head is, we subtract it, right? So read write head -1, else +1. Ah, cool. Let's see what happens now. And I forgot to update stuff. We updated the read write head. Now we have to update the dictionary index. So dictionary index, let's first do that. Dictionary index is temporary dictionary index, and dictionary row is temporary dictionary row. And we don't want this. Let's not do this. Cool. We clear the screen starting from line number 175 till the machine state is running. We clear the screen, call render, we render the everything. If read write head is 9, machine state is halted, else temp dictionary row is state dictionary index dictionary row second is the state. We get the state, we get the index using whatever we read out of it, and we write whatever is in the 0th column, and depending on the first column we change the values. Cool. So let's see what happens. So Turing.py, so we have some, okay, it is lagging pretty badly, but let's make this sleep for 2 seconds. Maybe that would relax it a bit. Okay, we also want to implement okay, I want to implement the arrow properly because it's kind of messy right now, but whatever, we want to implement that properly first. Okay, so yeah, so we have this. Okay, you have to work with this function first. I think we'll be done in 5 minutes now. 5 minutes, 6 minutes, I guess we'll be done. So where is the function now? There you go, yeah, over here. So hmm. Can we put this over there, like inside this? Let's try this. Hmm. Let's see what happens. It wouldn't not compile, but it would give me something which I don't want. I'm pretty sure, but okay, now it's doing it for both of them. I don't want that to happen. Don't want that to happen. If I is equal to current head state, okay, first of all, I forgot to. I think I got this actually. If dictionary should be current head state, and we also need to pass in the current dictionary index, and we have to pass that to what's it called? Okay, we first need to pass it to render itself though. We're gonna pass this dictionary index. Over here we accept current dictionary index, and we pass to the render dictionary thing, dictionary index, and we get this over here. And now if current dictionary is equal to current dictionary index, then we render this 1 2 3 4. Okay, now we must have something. Come on. Damn, there you go. Is it looping? First of all, it's kind of slow, so it's hard to tell, but no, it's not looping. Cool. Yeah, we have some. We have. I think it's almost done. So we gotta fix this padding. So over here we just do if current dictionary is equal to 0, we do this. Yes. Else we call the left padding 18 times and what the hell? Didn't work. Oh no, shit. No, this wasn't supposed to work like this. I'm sorry. We do call it this would be called like this, but okay. Oh, and I think I know what's happening. Oh yeah, I think. Okay, now I think then if we call the left padding over here, 13 times. But this should kind of work if I'm not wrong. Cool. And now we also need to do this over here. Very simple. If current dictionary is equal to current dictionary is equal to current dictionary index, then only we do this. Else we gotta print stuff normally, and the way we do it is by copying and pasting this. And okay, this is a bit weird. See this final thing and then we're done. We're not done. Why is there so many padding over here? Okay, there are two things to focus, and I don't know which one to focus on first, but okay, and so first of all, yeah, shit. Yeah, okay, so we do this if, yeah, we have to just copy this condition again. There is a better way to do it, but my language does not support it right now because it's a terrible language, but else we'll just randomly display a normal thing for display dot inline dot cool. Yeah, I think it's working now. Now only the thing is it would halt or not halt. It would depend. Uh, I do notice something that the value which we are I think there is some bug, but we'll take care of that. But what I want to focus on right now first is this, the extra padding. And that is happening no matter what, right? So I think it's going to be easy to fix because we can just make this What if I make this smaller? Like 10. I don't know. I'm just checking stuff. Yeah, I think good enough. 10 and let's make it 5, I guess. Let's see. Cool. Cool. It's working. Great. So we have this working. Now the only thing which we actually need to work on is, should I add a border over here, like an underline over here? Should I do it, or should I first fix the bug? I think there is a bug, because you know what we'll do is, what we could do is, first of all, what we could do is we could uh, yeah, we could give the user the ability to select the starting, ending, I'm gonna select the starting, index and the row of the machine. Cool. So we have this ready. We'll do that later. And first I'm gonna fix the bug. So the bug I'm talking about is, if I just sleep for, let's say, 5 seconds to analyze this properly. Let's compile this. Pilot wait, we did compile it. Now let's run turing.py. The case is, see, the case is, I think there is, oh wait, I think there is something, we just have to fix this, because this is case 0. Cool. This is case, we write 1, we are supposed to write 1 over here. Good. We are supposed to write 0 over here. This would, yeah, supposed to write 1 over here and state 6. We didn't read, what the hell. You see, we jumped over here for no reason. That shouldn't happen. Current state is 1. Value is 1. Supposed to write 0 and jump to 7. Even the shift isn't working. See, first of all, the shift isn't working. We're supposed to move left. We do move left. We're supposed to move right. We do move right, and we read 1. Cool. Supposed to move left again. See, this is not working. Okay, so okay, let's actually print stuff onto the screen. Let's actually do this. Let's do display. This is the movement thing. Let's do that, and cool. Now we would actually see, you would actually see that what is the value which we are reading. 0. See, this is the error first of all. Okay, it's 1 now, but we render this, we call this, so there is something wrong with this. Okay, I think I know. Hey Bhagwan, I am such an idiot. I am such an idiot. The dimensions are 2 times 10 times 3. So this has to be 2 times like 2 over here. What the hell is wrong with me? Okay, doesn't matter. I hope this is not changed because of that, but okay, but let's do that. So we we have this, we have 1 over here, we have 0 over here, we have again 1 over here, 3 and cool. Let's now actually try to see what's happening. Let's see. Okay, now this is terribly wrong. First of all, this is not supposed to be 3. How is it 3? Let's print all the 3 values to see what we're talking about. Let's do 0, 1, 2. 0, 1 and 2. 0, 3, 2. 0, 3, 2. 0, 0, 3, 2. Damn. Okay, there is something terribly wrong with our program because this shouldn't work like this, obviously. Okay, so I think I need to go over the dictionary thing again, or like the array thing again. So we have a 3D array, 2 times 10 times 3, yeah, cool. And the first is for dictionary 1 and yeah, blah blah blah. Okay, no, 1 second. The second, no. The second would be the thing now. Like the second is supposed to be the row. What's wrong with me? So there is no error over here. I misinterpreted some things. And I need to again edit this again over here. 2 and this would be 0 and this would be 1. Cool, let's again go through this. Oh yeah, I think it's good now. Cool. Zero zero four. Now what is 004? So why are we, if this is the row, okay, first of all, if you notice this, dictionary row is 5, first, second, third, fourth, fifth. Okay, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. This should be highlighted. Why isn't this highlighted? That's the issue now. So we have to go to the render dictionary, I think. Yeah, and now thing is, I have written such a cluttered code, I don't even know where to start fixing stuff. Current head state. Oh, wait. We don't need to, oh my god, we don't need to correlate this with the current head state. We need to correlate this with the dictionary row. That's why. So we simply pass in current. Okay, now we have to edit this every time. So current head state. Okay, let's find something. Let's find current head state. Only 4 occurrences. Okay. You can call it current dictionary state. call it current dictionary state, and we'll again call it current dictionary state, and we again are gonna call it current dictionary state. We don't have anything else. Cool. And to this we have to pass in the current dictionary state. So to the render function we pass in current index, and let's pass in dictionary index and one second, dictionary row. Yeah, in the render we accept the current dictionary dictionary row, and we just pass it down over here. We don't need the head state, we just pass it down simply. I hope it works. Dictionary row. Cool. And we are accepting the current dictionary state. We gotta change this also. Why? Okay, let's wait. No, one second. Current dictionary index, not current dictionary index. We copy this, get rid of this entire stuff, and 4 occurrences, right? 1, 2, 3, 4. Right, okay. Dictionary row, and then finally row. Cool. So I think we would be good now. Oh, one second. Let me just get rid of all the stuff which we had. Like, we don't want this. Hopefully, I think it would work now, honestly. I mean, let's see even if this compiles first. Cool, it compiles. Let's now clear the screen and let's now run it. Okay, let's first check shift. It should go forward. Cool. It should go backward, and write 1 and go backward. Great, it's working. And it should write 0 and go forward, and it should go to here. Cool, I think it's working. Write 1, go back, state 4. Write 1, go back, state 4. Great, it's working now. Great. So there you go, guys. We finally have a Turing simulator in my own language, in the language actually which we created, which you followed the development process, maybe or maybe not, on YouTube. I don't know. I mean, the first video does have 450 views currently, which is very high by my standards. So I could actually change this to a better color, but I am too tired right now, and I think my mind is too I'm too saturated with this code. Honestly, I'm not very happy with this. I mean, I did write this. I'm very happy. Like, at least my language is so extensible that it can actually simulate this. But I could have written this in a better way. But I'm happy with what I've written. Should I make some more changes? I mean, how long is the video? Let's just make some more changes. So, first of all, what we could do is we could change this color. This color is kind of weird. Let's pick yellow. Do yellow and white look good. Let's do vim box.py display yellow. Okay, one second. Background. Oh no, wait, what the Yellow looks more terrible. What the hell? You know, what I could do is I could actually, instead of just, I could change the color. Do I really want to have background colors with this? Yeah, I want to have background colors. Let's set the background color to be red. Let's see what happens then. Uh, Background is, damn, red looks very nice. I'm using red. Cool. I'm using red, and for that I could use purple. Yeah, let's actually work on making this look a bit better. It looks good, at least by my standards, but still. So mousepad Turing.py. Purple. No, it's not purple. Is it purple? Yeah, it is purple. Okay. Okay. Not that much, but okay. Let's set the background to be red over here, and background to be 1 2 3 4 5 6 red, and then let's search for purple again. Cool, we have this over here. This, let's change this to be red. Cool. Now let's pilot Turing.py and Turing. Cool. uh, 0 1 2 3. Let's call it row. I think first we'll edit this to okay, I'm gotta open mousepad over here. Damn, why is this so slow? 1 second. I don't know what happened. This became very slow. Let's close this. Cool, we have something. Now over here, okay, the state would halt, but that's the thing. It would halt sometimes. Maybe it wouldn't halt, or maybe it would halt. It would, doesn't matter. But uh, that's actually the halting problem. Like giving the initial state, I guess that's the halting problem. Giving the initial state can determine whether the program would halt or not. But whatever. So it's going good. We are doing good. We just need to focus on the coloring a bit. So mousepad Turing.py. We change the jump. Let's call it jump. Okay, let's call it roll. Doesn't matter. We 1 and 2. 1 and 2. Cool. We have this. Yeah. Should we give it a color? Let's give it a color of green, let's say. Okay, now let's do mousepad turing.py. At the top, or actually at the bottom, what we do is current read write head offset current tape state, render the tape, right? For rendering the tape, should we add some padding? It would look good actually. Let's try adding a padding of some values. Let's try. Let's try. Uh, Render. Where is render tape? Render tape. Render tape. Render tape. Oh yeah, cool. What we'll do is we'll call padding left of, let's say, 10. You know, let's call it local padding LP, because we would be changing this value often for now to see which suits the best. So we don't want to edit this in 3 places. We call the left padding and we supply LP local padding. Cool. Pilot turing.py. Padding left is undefined. What the hell? Padding left, padding left, padding left. Oh, it should be left padding. Sorry. Over here also left padding. Cool. And now, looks good actually. Not that bad. Let's try padding of 20. Yeah, we can do more. We can do 30, I guess. I think this is good. And now if we run this, yeah, great. This looks good. And now I just need to fix the header thing. Render tape, render head. Where is render head? LP is 30, right? Cool. Do we need to define this? Let's just call there's no point in writing a variable because we have fixed something now. So we have fixed this value now, so whatever. Where is render head? Over here. Cool. We need to add 30, right? Cool. I think this should take care of it. I did implement a reverse Polish algorithm, so that would take care of the pedmas rule. Yeah, 0, 1, 2. Cool. And now we could just also offset this by some value. Yeah, so I think we could just offset, call again, let's call it local padding. Local padding is, actually it makes more sense now for me to do it over there using LP, because local padding, let's just call it local padding is 30. Pass in local padding. Over here also we pass in local padding, cool. Now over here for the render dictionary thing, let's take the local padding to be equal to this local padding. Then for every row, we first call the local padding function. Not very hard to implement actually. For the first thing, it didn't work. Why is that so? Oh, that's why. We first need to call the new line because we did pad 10 times, but then we called a new line. So okay, now I think only for this thing we need to call the local padding. Call left padding. Would this work? Local. I don't think so. I've implemented that, but let's simply write this 23 and 28. Let's see what happens then. Not 88 or 28. My entire program would break then. Okay, what the hell? Oh, we're not supposed to change that, right? I'm sorry. Only supposed to change the left thing. This should work now, 100%. There you go. So now we have this, and I'll change the time now to be equal to, let's say, 1 second. And now, finally, after 3 hours, maybe, yeah, 3 hours, 4 minutes. Finally, after 3 hours, we have a Turing simulator in our own language. So I'm very happy with this actually. So yeah, thanks for watching this video, guys. I think I talked about like, you know, I wanted to write a pseudo random generative algorithm for my compiler, and I actually talked about this in between. I talked about how I wanted to implement this using the rational properties of pi. And maybe in the next video we're going to be implementing that. If you want to look this up, you can search for we'll just close this. Yeah, you can search for Bailey Borain, the Bailey formula. Just search for Bailey formula for pi something. There are 3 scientists. Bailey, I'll just look it up 1 second. It's Bailey Borwein Plouffe. Oh, sorry, Bailey Borwein Plouffe formula for pi. So this would give us the nth digit of pi. So through that we could work with stuff, try to generate random numbers, and the input value would be the epoch time. We would take in the epoch time as the seed, and then we could offset by that. So I have this in my mind. Maybe if I'm free, I'll try to implement this. Actually, I'm cluttered with my college work and my college assignments, but whatever. So yeah, that's for the video, guys. I'm going to be uploading this code separately. I mean, I do have my GitHub repo where I write I link all of the code and everything which I talked about in the description down below. I have this entire code base in the GitHub, so you can check it out. I'll link this program specifically in a different repo, I guess. So you can also check that out. So that's it for the video, guys, and thank you for watching. Bye bye.